Hello and welcome to the training video of Vertex Anti-Surge Controller configuration. In this video, we will see overview of single-stage anti-surge configuration. Before moving to configuration, let's quickly recap the basics of Woodward anti-surge controller. The green colored zone is a stable compressor operating area. In that zone, we see red PID over here and decoupling. So in this area, we see red PID and decoupling actions which are deployed. The yellow zone is protection active zone, this zone. In this zone, anti-surge controller is active, and if we go further to the orange zone, we see that there is additional step response routine, which is also known as boost response. Finally, in the red zone, there is surge area. Surge detection routine on cross line is activated into this zone. Now, let's observe the movement of operating point in the event of surge. Pay attention to the OP, that is operating point. You can see due to process disturbance, point should move from A to B, and we also will see that operating point value should drop from 130 to lower side towards the 100. There you go. Now we cross the line and we got the surge. So did you notice that the moment we cross the red line, the then operating point was much below than 100. So that's the distance which we defined, how much deep we want to go from the surge control line to the actual configured surge line. So at this level, we understand that we are familiar with the basic concepts of anti-surge controller. Now, moving to next step, before moving to the configuration, there are a few critical documents which are used for configuration. First one is thermodynamic datasheet. As you can see on your screen, this datasheet consists of gas properties related to various operating conditions. In this datasheet, we can see the operating cases such as normal, rated, turn down, lean gas, alternate, and rich gas. Each operating case has its own inlet and discharge conditions, such as molecular weight of the gas, suction and discharge conditions. You can pay attention. Each case is normal or rated. They all have their inlet process conditions, the pressure, temperature, humidity, the ratio of CP by CV. So these things are given on this anti-surge configuration datasheet. This is also known as thermodynamic datasheet. Note that these parameters reflects rated condition of the corresponding operating conditions. Out of these operating conditions, we select only one of the configuration inside Woodward's. If no specific information is given by customer for specific operating conditions, we select most used or most common operating condition for the configuration. If we feel that all operating conditions are equally used, then in that case we will select the most conservative condition, preferably when you get the highest flow at rated condition. That's the operating case we will select. Now moving to next document, that is compressor performance map. This map is also known as surge maps. On the right hand side, 3 maps are displayed. All 3 have got compressor flow as their x-axis, inlet capacity, actual meter cube per hour multiplied by 10 raised to power 3. Now if you pay attention, then you'll find there are three kinds of map shown here. The first one is discharge pressure versus flow. Second one is polytropic head versus flow. Third one is shaft power versus flow. The most common one is polytropic head versus flow. However, some of the user they need discharge pressure versus flow. We can use polytropic head versus flow configuration, and later we can change the map display type to discharge pressure. Another map display type is pressure ratio versus flow, which is not mentioned here, but that is also common. If you see on your left hand side, you will see there are another two sets of map. The one is discharge temperature versus inlet capacity, that is flow, and the other one is efficiency versus inlet capacity. The efficiency curve is useful for the configuration purposes. We need to get rated condition efficiency from this map. And second thing is that we need to figure out that what are my choke points. In order to find those choke points, we need this compressibility map. Next important document is flow device calibration. Essentially, we need this document to define the relation between differential pressure generated by installed flow measuring device such as orifice, venturi, pitot tube, and so on, and corresponding flow which is used for compressor control. The flow Q is equal to differential pressure multiplied by a constant. This constant factor, which is also known as C term, is determined by this data sheet. The information available on this sheet is mostly calibration of flow device. That is, at defined pressure, temperature, gas type, how much differential pressure is corresponding to flow. This will determine our C term. Next is very important, but oftentimes we overlook those data. Two more important documents. Number one, PNID of the process. Why do we need PNID for this process? As you can see on your right hand side, this PNID reflects that the location of flow measuring device, whether it is in suction side, means the suction of the compressor, or it is in the discharge side. In this PNID, you can see the flow measuring device is located in the discharge side of the compressor. Now you can also figure out number of heat exchanger, or if the heat exchanger is after the anti-surge valve or before anti-surge valve. Preferably, we want heat exchanger after the anti-surge valve. Now, from the PNID, we can also figure it out how much or how many overall control schematic we need. For example, in this PNID, we need one anti-surge controller, and we also need one performance controller to control the speed. The third thing is, which is very useful for control narrative, is the startup or shutdown sequence. How do we want to start the compressor? How do we want to shut down the compressor? So control narrative is oftentimes not provided by the customer. So it is always good to ask customer to get control narratives. Now, once we are done with those documents, a great practice is to draw a layout plan. What we want to keep in layout plan. So first of all, it is always useful to draw a layout of the configuration plan. So remember, the plan should have at least list of input and output with their corresponding ranges, units, and location of the transmitter. Next, the layout should have control loops. How many anti-surge controllers are there? How many or what kind of performance controller is there? Is it driving an IGB, or is it driving on a steam turbine? Are we having load sharing controller? Any limiter loop such as motor current limiter? Also, sequence of startup and shutdowns. Those things we need to make very clear on a layout of the configuration plan. After drafting the layout plan, we always come the first question. That question is, should I start configuring input output or train configuration first? So basically either way we can do that. In this example, all the units for critical sensor such as differential pressure or simply pressures like suction and discharge, temperatures, they all are finalized in the train configuration. So here we decided to configure train configuration. There is a routine for configuration check. If any section or any function is configured and if there is no corresponding input output, then user will have configuration error. In this section, we will start configuration process based upon the data provided. Make sure that you have access to the data which we mentioned in the beginning of the slides. When Vertex is powered without any previous configuration, we get this screen. As you can see here, Vertex unit is not configured. To configure Vertex unit, bring Vertex configuration mode and IO lock active. Once we are in IO lock, then access the configuration page. Now we are on the train configuration page. You can see here on this screen there are several options to start with the train configuration. What we are going to achieve here, we'll define units and standard conditions, we'll define number of stages. Do we have one anti-surge or two anti-surge? We'll configure the selection of speed or current, layout such as flow and temperature, whether flow is in suction or discharge. Also, we'll do carry out flow device calibration. We'll define compressor surge map and rated condition, gas condition, and we will also finish a preliminary anti-surge controller configuration. Ensure that on this screen, on your top right corner, you have user label as configure and mode as configuration. You can see on the screen on the top right hand corner. So we will start first from the train configuration mode. Now you may wonder that why we are not doing performance controller or limiter. So those things are separate and separate training videos. On the train configuration, you can see we have to use this thermodynamic datasheet. From this datasheet, we can access useful data. So first page, if you click on train configuration, you will get compressor 1 selection. Since we have only one stage, so we'll select standard algorithm used. Compressor 2 selection, since we have not used, so ASC2 not used. Then it asks about the compressor driver. This option is only for the display purpose on the overview screen. So in my PNID, I see compressor is driven by motor, so I'll use motor. The next two sensors, speed and current. Are we using speed in our project? Yes, we do. And are we using current? Yes, we do. So these two options should be checked. The final selection screen should look like this. Standard algorithm, AC2 not used, motor driven, both sensors checked. Next is units defined in the controller. Now note that the units defined here in your thermodynamic data sheet, they all are metric units, such as degrees Celsius, kilograms. So first option we are going to select as metric or imperial metric units. Pressure units, kilogram per centimeter square, that in absolute. Next is temperature, degrees Celsius, flow unit for mapping, actual meter cube per hour, polytropic head units, that is Newton meter per kg, and flow element delta P is mmH2O. The load unit is kilowatt. So either you can select kilowatt, or if you use megawatt, then you need to use a lesser quantity of horsepower of the machine. Note that this load unit is not having any control impact. It's for just only display purpose. The next is altitude compensation and standard conditions entry. Unless or until you are not given by some other information from the customer, we should leave this as a default conditions. In this datasheet, customer did not provide any specific standard condition or altitude compensation, so we are going to leave that as it is, as a default condition. The last one under 10 parameters is external trips in trip relay. This is used if you want external trip to actuate Vertex trip output, Boolean output. Reset clear trip relay, which is very obvious. Trip on normal shutdown complete. So if you want that your driver to be tripped once you finish the normal shutdown condition, then check this box. In this case, I want that the moment I finish my normal shutdown, which is also called controlled shutdown, I should issue, or my Vertex should issue, a trip command. There is external push button on the Vertex hardware. Some user, they don't like to use that external ESD button, but I want that to be used in the plant. Unless you are not having any specific request from the customer, we can leave this as a default value. So we finished train configuration part. Now the next will be compressor layout selection. This is compressor layout screen. On this screen we will define where should be our flow meter, where should be our temperature transmitter. As you can see here, there is a box. It's called anti-surge 1 configuration. If you had chosen 2 stages compressor, you might have seen ASC2 instead of ASC1 here. So since we have only one stage, so this is ASC1 configuration. We will start from compressor layout, and in the last we will finish anti-surge controller. So select compressor layout and press enter. The first page shows you ASC1 layout screen. Since we are using standalone compressor, there are no other valve or compressor stage involved other than stage 1, so this is standalone compressor. There is also one option available where we use 2 stages but single anti-surge valve. If you refer the PNID, this compressor has only 1 stage and 1 anti-surge valve, so it is standalone compressor. Next is flow meter location. You might notice that in your PNID the flow meter is on discharge side. So on this option we will select flow meter as discharge side. Default, it is displayed flow meter as suction side. Temperature usage, we are using suction and discharge, so we selected that. Intercoolers. Intercoolers are mostly used in case of air compressor where we have several interstages. They are linked with the intercoolers, and number of intercooler impacts the efficiency. This is not an air compressor, so we are using no intercooler. As I said, air case, there is no air compressor used. So we use no error case. And this is the tag name of anti-surge controller, which will be used for the display purpose. Same issue for the description. You can write a small 2 or 3 word description of your anti-surge controller. The last option is use start position command. If we have dedicated Boolean input only for the anti-surge controller, then we'll use this option. In our case, we are going to use train start command as Boolean input, so we are not going to check this option. Now the next portion is the gas characteristic. For the gas characteristic page, we need compressor thermodynamic datasheet. Basically, we are interested to know based upon which operating condition selected. Remember, we can only feed one operating condition at a time for the vertex. And this can be fed while unit is in shutdown and in IO lock. So we have chosen normal condition after discussion with the plant operators. For the normal condition, gas molecular weight is 17.8. You can find those values from these details. Gas specific heat ratio. Now this is important. If your flow meter is on suction, then use suction side gas specific heat ratio. If your flow meter in discharge, then you can use discharge side gas specific heat ratio. Next is compressibility as suction. So this is provided over here, compressibility as suction and the discharge. In case of compressibility at standard condition, we don't know about that or not given by the customer, then safer side is to take average of Z1 and Z2. So that's about gas compressibility. The next topic will be to calibrate the flow element. Now if you go to the flow element, this is the default layout of the screen. Remember, we talked about the flow measuring device calibration datasheet. Now it is time to use this datasheet. You can see this is an orifice, and we found that we applied this pressure, this temperature, this specific gravity or density, and then we received delta P over here, 1250 mmH2O. So let's fill this sheet. This is the default one. So all the information from this data sheet should be inserted over here. And after having this all data, you'll get these values. Orifice plate, raw flow at sensor. Remember, we need raw flow from the sensor. It is most preferred. However, we have option to get compensated flow or square rooted flow, but it is highly recommended to get raw flow from the sensor. Expansion factor, unless otherwise you are informed that expansion factor is variable, then only you change it, otherwise keep it expansion factor fixed. Now method used. So primarily we use two methods to get the calibration of flow device. The first one is the calibration from the sheet. The second one is geometrical calibration. In calibration sheet method, we take process parameters from the data sheet, and taking process parameter, we define at given processes condition, we get this much volumetric flow corresponding to the delta P. The second method, we take geometrical factor of the device, such as small d, diameter of the device, pipe diameter capital D, beta ratio, those geometrical methods. The good standard way is to calculate the calibration by using both methods and compare. If both calculation final value of the C term is matching to each other, then it's great. Otherwise, need to do again all the calibration. Now you can see we inserted all the required data over here, and then once you are done with that, we need to hit on the calibration button. Before hitting the calibration button, note that this is the data which we received from the data sheet. Once we hit the calibration button, we'll get this page and enter this all data. At 64575 normal meter cube per hour flow, we received this much 1250 mm H2O differential pressure. This was my molecular weight of the gas, this was the pressure, temperature, compressibility, and it was not mentioned any percentage loss, so we left that as 0. Once you hit send calculated value to control, you will get configuration error, configuration OK button as a green, and the C term is saved into the controller. That finishes our anti-surge 1 flow meter calibration. Now the next task is to enter the compressor mapping points. Before going to compressor mapping points, keep in mind on the flow measuring device calibration that you use correct units. Oftentimes people make mistake to use incorrect units of the flow. For example, instead of normal meter cube per hour, some people use actual meter cube per hour. They are different. So be careful about those things. Next is compressor mapping. This is important step in compressor control configuration. For compressor mapping, we are going to use predicted performance map, surge map, also known as that performance curve. Basically, on this configuration sheet, we define what are my surge points, what are my rated conditions. So we are going to use the performance map, as you can see on your right hand side. Refer to the first screen. The first is status of actual map, that is for the status display purpose. Type of map entered. So most common is polytropic head versus flow, the center one map, this one. So we are going to use this map type. Type of flow for mapping, you can see on your flow axis, this is actual meter cube per hour. So we are going to use ACMH. The pressure units in absolute for mapping. So you can see pressure units on the map, they are in absolute. Kilogram per centimeter square A. This is polytropic head unit. And we have selected 5 points. You can see here 1, 2, 3, 4, and 5. A normal convention is to use minimum 3 points. If we want to use choke map, then we can use choke. Remember that Vertex is not having choke controller. It has option to create alarm on the condition of choke. It has option to show choke line, but there is no choke driver. The next is AC1 units and multiply factors. So here you can define the multiplication factor on your x or y axis. If you notice, on x-axis flow was in 10 raised to power 3. So we use this unit, E plus 0.3. Similarly, head was having multiplier of 1000. So these two factors we use. Next is the rated condition. The rated condition we enter from the thermodynamic datasheet or the compressor map at the point where you see a dot or circle. If you refer to the compressor map, you can enter suction temperature, pressure, and discharge temperature is calculated internally, so you don't need to enter that. Discharge pressure, actual flow at rated condition, rated speed. Normally, unless defined something differently, rated speed is considered 100% speed. And then we can use polytropic efficiency from the efficiency curve at rated condition. Once we are done with these values, then we can get a kind of estimated conditions like mass flow, aerated condition, standard flow, polytropic head, and calculated power aerated. These four values, remember, they are estimated condition. They may or may not be very close to the actual data on your map, but these values are a general reference for configuration of your surge control. For example, if mass flow is for reference estimated here 78,541, and if you see in your data sheet is way off somewhere 10,000 kilogram per hour, then there is some mistake in configuration. You should again revise your configuration in that case. But 10, 15%, 10% variation is okay. Once we are done with the rated condition, our next step is to confirm rated condition button. Once we hit confirm rated condition, you may notice that the status value is changed from rated condition confirmation to surge map update needed. Now next step is to enter your surge map. For this, if you remember, we selected 5 points for the surge map. On your compressor map, select those 5 points. Start from the lowest value. Remember that if you want to be conservative, then your calculated point or noted point should be just before from the actual point, so that you can get more conservative surge line. So calculate these values. You can use ruler or some software to figure out those points, and corresponding this point, Y factor is your polytropic head, that will go over here. X factor is your flow, which is coming to this axis. It will go on this side. Once you have entered, then you enter your speed percentage. Remember, we said that rated point, which is this one, is considered 100%. So this is speed point is 100%, and rest other are calibrated based upon that. Once you enter all points over here, then you press save all. If you press save all, then controller will save operating points or surge points into the memory, and after that you should see all data okay and used, and there should not be any red LED either in forced off or in error mode. Now next, if you are having choke map selection, then we need to further enter choke points. In order to enter choke points, the last bottom of these map lines, speed lines, reflect the choke points. If you put your efficiency curve behind this curve, you will find corresponding to this speed curve, we have lowest efficiency in the efficiency curve. So this is selected your first choke point, and corresponding Y factor will be entered as a Y1. Once we are done with that, click on save all, and then we'll get the final map display. There is your final map. You can notice that you have option to select the type of map. We entered polytropic head versus flow, but you can click on this button and select pressure, discharge pressure versus flow, or pressure ratio versus flow. Also, you can change the flow type, actual flow, mass flow, or standard flow. Now, another point of interest is this map is automatic scaled for you, so that you can have the visible upper and lower boundaries of the map, a polytropic head as well as the flow. However, if you want to change the scale of the map, you can hit on this button auto scale off, and then select the maximum and minimum value of these maps. So once you hit on auto scale off, you have option to select what should be the Y maximum, Y minimum, and the Modbus multipliers, flow, X min, X maximum, X minimum, both. So this concludes our compressor map configuration, compressor layout configuration, gas configuration. Now we are coming to the anti-surge valve configuration page. There is not very specific things to configure over here. Since we don't have the actual commissioning response of the units, so we are not going to use gain compensation. Valve minimum and dither, they are also not used. If you want that operator should not have access to the full manual mode, then check this option, inhibit full manual. In some of the plant, many times you want your valve to hit more than 100%, 102, 105%. There you can use overstock. But since we are not in the field and we don't know our valve is having some inertia or any plug and seat issues, so we are not going to check this option. The last configuration is control configuration. These most of the parameters in this configuration are available into the service section. So here we can skip something which can be tuned during the running machine, such as decoupling, rate PID, display settings. Those can be tuned in the running machine as well. So let's go quickly and see what parameters should pay attention at this configuration stage. The first one is sequencing and online detection. We want that shutdown should be active even if you're in manual position. So shutdown manual position is enabled. These are the position. Default you can leave as it is if you're not sure. For example, position just after shutdown. In some of the application, operator don't want that you start your unit at 100% opening. So in that case, we can keep it at 80%. Do you know what those conditions could be? Try to remember. We'll talk about that. Zero speed and zero current, you define that this amount of amperage or this amount of speed I will declare as no speed or no current, so that my valve position should reach to the zero speed position, which is equal to the shutdown position. This is the delay of the shutdown if zero speed or current occurred. So that is equivalent to the shutdown position. During startup, what the position you want, those things you can configure over here. Next is sequencing and online detection. Online, if you remember, that means your anti-surge controller is deployed and is in action. If your anti-surge controller is not an online condition, then no matter what happens, it's not going to issue surge detection or any protection routine. In this stage, we have figured out that minimum speed to start operation is somewhere around 8,500 RPM, or sorry, it is 8,800 RPM. So we use little bit lower than that value, 8,600 RPM as minimum speed level. We also have several other options such as external contact, that is kind of a load button. This load button can be used as to bring the machine into the online condition. Remember, if you select more than one option, trigger option for online detection, in order to get online, all of them should have to be at the triggering level. If any one of them is not active, then anti-surge controller will not go into the online condition. Next is sequencing valve rate. If you're not sure, and since we are right now in the configuration mode, so we'll keep those sequencing valve rate at default conditions. The actual conditions are determined during the time of commissioning. This page, we want to figure out the normal shutdown state. We want that normal shutdown on the train normal shutdown command. So we selected the option. We have not been informed either by the control narrative or any IO point for the purge command, so we have not used. Otherwise, we have option to select purge condition. And we can also define what should be the purge position. This page defines the surge detection methods. Do we want surge detection of flow derivative, minimum flow, discharge pressure, speed derivative? The most common other than the surge detection on cross line is speed derivative detection. Another one is motor current derivative detection. Since we don't know the process condition, so at this stage during configuration, we can leave surge detection on cross line checked and go for the next stage. This one is surge detection, but basically we talk about what action should we take when we detect surge. The first thing is loop period. If you have read into the manual, you remember that this is the response time of the process. Again, we have not configured, we have not commissioned the unit in the field, so we don't know the loop period. So let's keep it 10 seconds, the default values. We don't have external surge detection contact, so it's unchecked. Surge recovery, we checked it. Surge minimum position, checked it. Control line shift is also checked. So default, we have a conservative response for the safety purpose. Next is the boost line and surge control line margin. Keep this margin as default value unless you have some specific concern of the site. We have already configured a bit conservative surge control line margin, that is 30%. Even if you think that this margin is little low, you can go for a safer side for 35% or 40%. The maximum amount allowed is 50%. Consecutive surge and alarm counter. This consecutive surge trip should be activated because most of the time what happens when we run or when we start the compressor first time, there are lots of foreign particle comes into the compressor pipeline, and even if your anti-surge valve is 100% open, it is choked from the inside, and that brings unit to the surge. So for the first one or two startups, ensure that your consecutive surge detection trip is active. In this project, we have not given the valve feedback, so there is no option selected for the valve feedback actions, and also full manual mode is inhibited. Signal conditioning. On this phase, we don't know the actual condition of the field, how much transmitter are having noise on the field. So we'll keep fallback strategy as most conservative, signal conditioning as most conservative one. We are not using smart suction or smart discharge temperature because the user has provided both suction and discharge temperatures. Now we want to use default value settings. So these default values, primarily we take it from the compressor rated conditions. So you need to enter the condition from the thermodynamic data sheet. Now we don't know, should we use a pressure ratio if P1 fails, or should we use pressure ratio when P2 fails? So these things need to be discussed with the customer at the site. If they have any specific concern, then we should check it. Otherwise, we should go with the last good value. These are the field signal fault action on the control. If you want to add some extra values in case of flow transmitter fail, we can add that value to here. These values better at this stage left as per their default conditions. And the best way is to discuss with the customer and figure out that these options, the both parties, you and your customer, should discuss the pros and cons of these fallback strategies. For example, let's say you want to discuss with your customer full manual mode selected on any fault. So you need to explain to the customer that if any fault happens, whether it's a pressure, flow, or temperature, the controller will go into the full manual and you won't have any surge protection activated. So it depends upon the customer. If you're not sure or your customer is not sure, it is safer to leave as a default values. Now, these are the signal filtering. Woodward use ARMA filtering, that is proprietary method of filtering. You can leave this as a 000 for the default. These filtering values will be selected during the commissioning. The next is PNIDs. So in these PIDs, we talk about what should be our control set point for the pressure override controller or suction or discharge pressure override controllers. These values, if you are aware of from the field about the trip set point of suction or trip set point of discharge, then we should enter these values. Otherwise, we should talk to the customer and figure out what are the critical set point for the suction or discharge pressure. If there are no issues, if suction pressure goes very low or no issues for discharge pressure goes very low, then we don't need to configure override controllers. The same concept is applied to discharge pressure as well. There are auxiliary control. You can normally what you can do that check the auxiliary control HSS2. The advantage is that in the running machine, you can use Vertex screen and feed your own limiter. The HSS bus will not allow valve to close below this value. This is useful during commissioning. The first one is external HSS signal that is available, and customer can provide their own high signal selection for the anti-surge controller. Now, the last step, we finished actually the train configuration. The next step is to configure input output. If you remember that in the beginning we started with the train configuration. Now this is time to configure input output. If you notice that the critical parameters such as flow, the units are set into the train. We already defined those units inside the train controller. If you want more details, please refer to volume 35072, V1, V2 and V3. So once you are done with this analog input output configuration, we should now go for the configuration check. If there is no configuration check error available, then you will see no yellow light over here. Alternatively, you can hit on the configuration check button and you will see nothing is available in your configuration check errors section. If your configuration is not having any error, then you can go ahead and exit the configuration. The unit will save the tunables, and you should notice that your header turns from blue to the gray color. Now this one configuration option, you can see for the single stage compressor, you only see compressor 1 control button over here. Remember, if we use multi-stage like 2 stages compressor, you'll get another compressor 2 control. If we use performance, you'll get performance or load sharing buttons. So now you have done with your configuration. Congratulations, and there's finished configuration training section.